Okay, let's try to finish this here without me having more technology mishaps. So 2 hours later, after it's finally uploaded and your teacher's not an idiot and talking to himself, we can finish this question. So the final thing here is we can solve for this y variable, which we're going to get is -7, which I already have there. Like I said, 2 hours back. Okay, we also have to input this other x variable here into that same equation. And we should be getting 5. So our two answers here that we should be coming up with are -4, -7, and 2, 5. Great. Yet again, I think it's a great idea at this point to check these in the original equations and see that they work out. To save a little time here, I'm just going to check it in this one equation. So plugging in 2 here, we have 4 plus 8 minus 5. Does that equal 7? Oh yeah, it does. There you go. Now you can even see it. Let's talk about what this means, why there's actually two solutions to this compared to the one in the other case. So what we have going on here is that this first equation is in fact a quadratic equation. So that means it's a parabola. So if we had solved for y equals, we would have this equation. And this isn't one that we can factor and make it look all nice and neat, but I do know that the general shape of this one is going to look something like this. Exactly correct, probably not, but just some rough sketches of a parabola that we have here. Now, this other line that we have here, 2x minus y equals -1. Solving for y here, we have 2x plus 1. And then we should know starts here. And look at that great straight line. Not quite. But the point is still valid that it crosses twice. So that's why we have there two solutions here at 2, 5, and -4, -7, which we obtained right down here. Okay. 2 more questions. Okay. Another system of equations we're solving here, and this one is still a quadratic. So maybe we're thinking like before, we're going to have 2 solutions. Let's go through and see what we're going to get here. I'm going to play the same exact game as we did in the one last time. And let's start up here, since we have the x squared down here, and let's solve for y. We have x plus 4, so I can substitute that back into our other equation here. So x squared plus x plus 4 equals 3. Getting everything to one side, we're down to here. Okay, and if you try to factor this, you're going to realize that's not going to happen. So what we need to do here is still solve. And the only way we really know how to at this point is to do a little quadratic formula. Inputting the numbers we have here, b is going to be 1, so we have a -1 here, plus or minus 1 minus 4 times a times c all over 2a, which we could simplify to, and hopefully there's something big that stands out here, specifically that our discriminant, that b squared minus 4ac, is a negative. That's not a great thing here. What that's telling you is that there are actually no solutions here. And maybe you're thinking, well, how is that? We just went from a question where there were 2 solutions that look pretty much identical to this to one where now we have all of a sudden no solutions whatsoever. So let's take another graphical look at this and see what's actually going on here. Just like last time, let's start off by looking at this parabola shape. Negative x squared plus 3. This one we should have a pretty good idea what this looks like. It's a frowny parabola because of that negative here. And the plus 3 should be indicating that we're actually shifted 3 units up. So something along these lines. Okay, let's look at that other linear equation. Solving for y here, we get that it's x plus 4, which means we start up 4, which is 1 more than our parabola. And let's see if this line is better. Great. And notice if I continued that red line and the parabola, they're never going to cross. So in this instance, there are no solutions. So it does just take kind of working through different questions to see whether something can actually work out or not, and the graphs back up all the answers we've been getting. Okay, on to our very final real-world example here. So kind of like before, we had some company and same kind of thing here. So here, a small business invests $10,000 in equipment to produce a product. So each unit of the product costs 65 cents to produce and it's sold for $1.20. How many items have to be sold before the business breaks even? So think about this in terms of the real world. It costs $10,000 to just open a company. So that's talking your building, your electricity, all your supplies, all that stuff before you even do anything in terms of building each individual thing. So how can we represent all of that? So I can think of all of this as our cost. And it also costs 65 cents to produce each one. So our opening cost here is $10,000 and then an additional 65 cents per every object sold. But when we sell objects, all of a sudden that's a good thing. That's revenue we're making. And that is going to be 120. So cost and then revenue. And we want to know where we're breaking even, right? Revenue is per object. And our breaking even point is where these two things are equal to one another. And then every single kind of item you produce after that should hopefully be just money in the bank that you're making. So let's set these two equations equal and we'll go from there. So let's get all of the x variables on the right hand side since that one's already isolated. So we're subtracting that 65 cents from $1.20. That leaves us with 10,000 over here. Some hard arithmetic. Solving for x. And this isn't one I expect you guys to be able to do without a calculator, but it does come to approximately 18,182. And then we're going to think, what is that even talking about? Oh, that's like things or items or units that we're making. So whatever your company is producing, that's how many objects it has to make before it can finally break even. Everything after that is actually gravy, and they're making a profit. Okay, that's pretty much the gist of 7.1 there. If you recall, I had written out what the homework assignment was, and I think I'm going to tack onto that a little bit, which I'm sure you're all super happy about. That's what I gave you in class, was 15 to 28. Let's add on the additional 67 to 72, which are some real world questions. So how I want to work this whole kind of YouTube classroom thing is you can either email me any questions or concerns you have on these homework assignments. There we go, jjohnson4@SyracuseCitySchoolDistrict.us. or you can leave them in the comments below here of the YouTube page. And I think on Wednesday I'm going to get around to making a homework video, and we can go from there. Okay, be safe everyone. I'll talk to you all in another 2 days.